Okay, so we're going to talk a little bit about Module 3, Lesson 3 today. We're going to talk about how to add and subtract like fractions. So before we get too far into it, we need to kind of define what a like fraction is. So like fractions are fractions that have the same denominator value. So 1/3 and 4/3 would be an example because the denominator values are the same. Okay. They can have more complicated denominators. You can have like 7 over 3x and 5 over 3x. But those fractions are still like because the denominators are identical. That's what we're looking for there. Unlike fractions, on the other hand, are going to be fractions that have different denominators. And adding and subtracting unlike fractions is much more complicated. We're going to deal with that in a later lesson, but we're mostly focused on the fractions that have the same denominators today. Okay, so when we're asked to add like fractions, they'll look something like this. The denominators have to be the same. Then all we're going to do is we're going to add the top, and we're going to keep the denominator the same. So if we have an example like 1/3 plus 4/3, okay, those fractions are like, so I'm just going to add the top. So 1 plus 4 is 5, and keep the denominator value the same. So 5 over 3 will be my answer here. You do need to be careful when you're adding or subtracting these like fractions because there's no guarantee that this answer that you get is going to be in lowest terms. So you do need to take a second to look for anything in common on the top and bottom, or anything that divides evenly into the top and bottom, and take it out if so. In this case, 5 and 3 don't have anything in common, so this is a fraction that's in lowest terms, but this is not like multiplication and division. If we did the multiplication thoroughly, we looked for all those common factors before we multiplied, our answer was always in lowest terms. There are no guarantees to that effect when we're adding or subtracting. We do need to check our work and see if we can reduce the fractions at all. Okay, so let's look at a few more examples. Let's look at another simple one where we do have to reduce. So if we're going to add 5/12 plus 1/12, again, these fractions are like. So I'm just going to use the same rule. I'm just going to add the top. So 5 plus 1 is 6, and then keep the denominator the same. But now 6 and 12 are both divisible by 6. 6 goes into 6 one time. 6 goes into 12 two times, and so 1/2 is going to be our reduced fraction. So a good example here of a problem where we did everything correctly when we added the top, kept the bottom the same, but if we hadn't reduced to lowest terms, we would not have gotten the final answer correct. Okay, now we can certainly do this same kind of thing with signed numbers. So if we have something like this, negative 7 over 25 plus 2 over 25, okay, just because we're dealing with fractions doesn't change how our signed number math works. We're going to add the top, so we're adding negative 7 plus 2. My signs are different. Got to go back to what we learned in Module 1. My signs are different. I'm going to subtract, so 7 minus 2 is 5. And then I'm going to take the sign of the bigger one. The first one's bigger, and it's negative, so the answer is going to be negative, and then I'm going to keep the denominator the same. And then, like with all of these problems, we do need to take a second to try to reduce to lowest terms. 5 divided by 5 is 1. 25 divided by 5 is 5. So negative 1/5 is going to be my answer here. Okay. Now the nice thing is the rule for subtraction is identical. It's no different at all. If we have a problem like 9 over 22 minus 5 over 22, okay, we're subtracting like fractions. We can just subtract the top. So 9 minus 5 is 4, and then keep the denominator the same. And then our last step is to try to reduce this down to lowest terms. 4 and 22 both divisible by 2, so we can take that out and get our final answer that way. Okay, so addition, subtraction, really going to work the same when our fractions are like this. We're just going to add or subtract across the top, and then we're going to keep the same denominator, and then we're going to finish it up by reducing to lowest terms. Okay, we can have a problem where we have variables in the denominator sometimes. So we might have something like 8 over x minus 9 over x. It doesn't really matter that I have denominators that are variables. What matters here is that our denominators are the same. Okay, so these fractions are like, I know what's going to happen on the bottom. It's just going to stay the same. And then I'm just going to subtract across the top. Remember, you can think of subtraction as adding the opposite if you prefer. So I can rewrite this as 8 plus negative 9 if I want. And then my signs are different. I'm going to subtract and take the sign of the larger one. And then just got that x on the bottom, so there's nothing I can do to reduce. And so that's my answer there. Okay, so we might ask you to subtract some things like this, and it's very important in a problem like this not to do too much. It's very easy to try to do things that you're not allowed to do here. We do have like fractions, so the bottom is easy. We're just going to keep that bottom value the same, and we want to subtract the top, right? But you got to remember that these terms are not like. 5y and 9 are not like terms. You can't combine unlike terms like this. So the 5y minus 9, we're just going to bring that on over. And there's nothing else we can do. This is as simple as we can make it. We can't actually subtract those terms because they're not like. So we have to leave them separate. There's nothing we can do about that. Okay. I can certainly ask you to do some questions like this. We might ask you to find x plus y when x is equal to 7/5 and y equals negative 11/5. Okay, well, we're just going to plug these values in for x and y in our expression over here. So 7 over 5 is going to go in for x. Negative 11 over 5 is going to go in here for y, and then we're going to add them. And again, our fractions are like, so we can just add the top. So 7 plus negative 11, signs are different. We're going to subtract those values. Take the sign of the larger number and keep that denominator the same. So hopefully you remember all your Module 1 stuff because it's a big part of what we're doing in kind of everything in this class. Okay? Okay, so the last big idea in this section is something that will lead into adding unlike fractions in the next lesson. It's asking us to find equivalent fractions that have different denominators. Okay, so in this problem, it asks us to take the fraction 6/7 and change it into something over 28. We're trying to fill in the top of this second fraction. It gave us the bottom value of 28. So the question that you want to ask yourself here is, what do I have to do to this 7 to make it into 28 with multiplication? Okay, so 7 times 4 is 28. And the deal with fractions is if you want to find an equivalent fraction, and you're multiplying the bottom by something, you have to do exactly the same thing to the top. So because 4 over 4 is equal to 1. So if I do a times 4 on the bottom to make that into a 28, I need to do a times 4 on top to keep my fractions equivalent. So 6 times 4 is going to give me 24, and that's what we're looking for here. So 6 over 7 and 24 over 28. Those fractions look very different, but they're actually equivalent values. Okay? Let's do one more of these. You can have something like 2/3. Try to change this into something over 18, for example. Okay, so the question you want to ask yourself here is, what do I have to do to this 3 to make it into an 18? Multiply it by 6. And then whatever you do to the bottom, you have to do the same thing to the top. So we need to multiply by 6 up here as well. So 2 times 6 is going to give me 12 over 18. So 12 over 18 is equivalent to 2/3, but it has that denominator that I was looking for. Okay, so hopefully that's enough to get us off to a good start in Module 3, Lesson 3. Just let me know if you have any questions as you're going through it, and you all have a good day.